Hello all, welcome to Easy Electronics. So in this video we are going to discuss about strain gauges. We'll be seeing the basic principle of strain gauge, the structure of it, and also the working of that device. Okay, so we'll be discussing about all basic things of a strain gauge, and also we'll be seeing the 10 important questions that can come from the strain gauge session. Okay, so if you're preparing for any competitive examinations, especially for ISRO technical assistant exam or any other diploma examinations, or any other competitive examination for that matter, these type of questions are very important. Okay, so strain gauge is a very important topic, so we are going to discuss about the strain gauges in this video. And if you found the video useful, please don't forget to like, share and subscribe. Now let's see about strain gauges. So in today's class, we are going to discuss about the strain gauges. So strain gauge is a device which is used to measure the strain of an object, and it is working based on the principle called piezoelectric effect, which is stating that the conductance or the resistance of a device or a material, it is depending on its geometrical structure. That is, consider that the length of the conductor which we are using is L, and A is the area and rho is the resistivity. Then the resistance of the material or the wire which we are using is equal to rho L by A. So the resistance is depending on the geometrical shapes. Okay, that is, it is depending on length and area, right? So what will happen when this length and area is getting changed? The resistance will also get changed, right? So this is the principle, the basic principle behind the working of strain gauges. That is, when we are going to apply some force to a conductor or some conducting wires, then there will be some changes in its geometrical aspects like length and diameter. It will be changing. So when the length and diameter is changing, the resistance or the conductance of the wire will also change, right? So this is the principle behind the strain gauges. Okay, now let's see what is the structure. Then we'll connect the working. Okay, so the structure is consisting of a insulating base and a very fine metallic foil or a resistance wire connected on top of it. Okay, so there is a metallic foil pattern placed on an insulating base. So this base is an insulating type, and above that base there is a metallic foil pattern which will be a fine resistance wire placed on top of a insulating base. And if you want to measure the strain of some object, we'll connect this strain gauge or this pattern to that object with the help of an adhesive. Okay, so consider that we want to measure the gauge of an object. So we'll connect the strain gauge with that object using an adhesive. Okay, so this adhesive can be cyanoacrylate or bakelite cement. So when the strain gauge is placed closely or it is connected using an adhesive to an object, what will happen? When we are making some deformation to the object, the strain gauge connected to that object will also get deformed. That is, this metallic wire will also get deformed. That is, it will undergo some changes in its length and diameter. Okay, that is the length and the diameter of this wire, that is this pattern, will get also changed, and as a result the resistance of this wire will get changed, and we'll measure the change in resistance of this wire which is in the strain gauge using a Wheaton's bridge. Okay, and there is an equation connecting the gauge factor, change in resistance and the strain, and using this formula we'll find out what is the strain associated with that object. Okay, so in simple words we can say, whenever we want to measure the strain associated with an object, we'll connect that object with the strain gauge using an adhesive, and whatever deformation we want to or whatever strain we want to give to that object we'll give, and as a result this wire on the strain gauge, that is this metal foil on the strain gauge, will undergo some deformation due to the applied strain on that object. Since they are connected with an adhesive, there will be a change in dimensions of this metallic foil also. Okay, so when there is a change in dimensions on this metallic foil, that is considered that there is a change in length and diameter. So what will happen? There will be a change in resistance also. This change in resistance will measure and we'll find out what is the strain on that object. Okay, so this is the method of measuring the strain of an object, that is, or the strain given to an object using a strain gauge. Okay, that is, if you want to measure a strain of an object, we'll just connect that object with the strain gauge using an adhesive. Okay, and the adhesive can be either cyanoacrylate or bakelite cement. Okay, and we are actually measuring here the change in resistance of the strain gauge wire. Okay, we are not directly measuring the strain from the object, but instead of that, we are measuring the change in resistance of this strain gauge wire, because again, the principle that the resistance or the conductance of the wire is depending on its geometrical shapes or geometrical structures, that is length and diameter. Okay, so when strain is applied to the object, as a result, there is a change in the dimensions also, right? So this change in dimensions will lead to the change in resistance, and as a result, we can find the strain using this formula. Okay, so consider that there is a conductor which is been having a length of L, diameter D, and we are going to apply some forces, some deformations or some forces to the ends of the conductor. What will happen if we stretch the conductor? The length will increase, but the diameter will decrease, right? So these type of changes can happen when we are applying some strains or some forces to the object also. Okay. Now, what is the equation connecting the change in resistance, the gauge factor, and the epsilon? Now, what is gauge factor? Gauge factor is defined as GF is equal to delta R by R to delta L by L. Here, delta R is the change in resistance, R is the original resistance, delta L is the change in length, and L is the original length. Now, this is the GF, which is the gauge factor. Okay, so this is the gauge factor, and generally for the strain gauges with metallic foils, it will be slightly greater than 2. Okay, so the value of GF will be slightly greater than 2 for the basic strain gauges which we use. Okay, so the value will be almost greater than or equal to 2. And also, the strain is given by the equation delta L by L. Okay, so the variable GF is representing gauge factor, epsilon is representing the strain. Delta R is the change in resistance and RG is the original resistance. Okay, so if we know the original resistance of this strain gauge wire, and when we calculate delta R using Wheaton's bridge, and if we know the gauge factor, then we can find the strain. Okay, and also we'll find the change in resistance using a Wheaton's bridge. Okay, so the Wheaton's bridge is used to find the change in resistance. We have already discussed about Wheaton's bridges. We know that Wheaton's bridges are generally used to find the change in resistance or the unknown resistance value. So in order to find the change in resistance or unknown resistance of this strain gauge wire, we'll connect the strain gauge wire to one of the terminals of or one of the branches or arms of the Wheaton's bridge, and we'll find out the change in resistance. Then we can find what is the strain value on that object. Okay, so this is the principle of operation of a strain gauge, and this is the structure of a strain gauge. The strain gauge is a very simple structure. It is just consisting of a insulating base and a metallic foil pattern on top of it. Okay, and we are going to connect the strain gauge to whichever object we want to measure the strain with an adhesive. Okay, so this is the basic working principle of a strain gauge. Next, we are going to see some important questions from the strain gauge topic. The first question is, electrical strain gauge works on the principle of dash. I'll read out the options for you. So, variation A, variation in resistance, B, variation of capacitance, C, variation of inductance, D, variation of area. So the correct answer is A, variation of resistance. So we have seen that we use a metallic wire or a metallic foil pattern in the strain gauge, and whose resistance will change, and we'll measure the change in resistance using a Wheatstone's bridge, and that resistance change we use to find the strain, right? So here the answer is the variation in resistance we use. Variation in resistance is the principle. Okay. The variation in resistance of the strain gauge wire. Okay. Second question. Bonding element in strain gauge must have dash. The options are 0 insulation resistance, B, low insulation resistance, C, high insulation resistance, D, infinite insulation resistance. The correct answer is the bonding element of strain gauge. Bonding element means the adhesive. Okay. So the adhesive of the strain gauge must have high insulation resistance. So in strain gauge, the bonding element must have a high value of insulation resistance. It should be immune to effect of moisture and must also have the ability to transmit strain. So in order to measure a strain of an object, so consider that this is the object which we want to apply the strain, and we want to measure the value of that strain. So we connect the strain gauge to this object with the help of a adhesive, right? Adhesive or a bonding element. We can call it by both names, bonding element or adhesive. Okay. So this bonding element or this adhesive should have a high insulation resistance. High insulation resistance this bonding element should have, and also it should be immune to moisture, and also it should be able to transmit the strain properly to that strain gauge. So this strain we apply here should get transmitted to the strain gauge, and there should be some change in resistance of the strain gauge wire. Only then we can find out this value of strain. Okay. So this is the principle of a strain gauge. So it should have a high insulation resistance is the answer. High insulation resistance. Okay. Also, we have discussed what type of material we use for bonding element or adhesive. Third question. Commonly used elements of wire strain gauges are dash. The options are A, nickel and copper, B, nickel and gold, C, gold and brass, D, silver and aluminium. Okay. So the commonly used elements in strain gauge wires are nickel and copper. Okay. Should be knowing all these things. Nickel and copper are the commonly used elements in the wires. That is the strain gauge wires. Okay. Fourth question. Proper functioning of strain gauge depends on dash. A. The options are A, strain, B, stress, C, bonding, D, length of wire. Okay. So the proper functioning of a strain gauge is actually depending on the bonding. Only if the strain, that is when we are connecting an object to a strain gauge with the help of a bonding or a bonding element, only if the bonding is proper, then only the strain can get transferred to that strain gauge, right? So only if that bonding is proper, we'll get the accurate strain measurement values. Okay. So the correct answer is bonding is the correct answer. Only if the bonding element or the adhesive is proper, only then we'll get the proper functioning of the strain gauge. Next is a relation. We have already discussed the relation. Gauge factor is given by which relation? Okay, I'll directly write the answer. So gauge factor GF is equal to delta R by R by delta L by L. We have already discussed about this. So delta R is the change in resistance. R is the original resistance. Delta L is the change in length. L is the original length. Okay. So delta R by delta L by L is the gauge factor of a strain gauge. Okay. The next question is question 6. Strain gauge measurement involves dash bridge. we have discussed that for measuring the change in resistance, we use a Wheatstone's bridge. Okay, so there is also some other type of strain gauges which make use of capacitance measurement, that is change in capacitance measurement and inductance measurement also. Okay, so there are some other variants of strain gauges are also there. Okay, next question. So here the answer is it makes use of Wheatstone's bridge. So the basic type of strain gauge is a change in resistance measuring type. Okay, so in that case we use a Wheatstone's bridge to measure the change in resistance. Seventh question. Strain is a strain is a fractional change in dash. Okay, strain is a fractional change in length. I hope you remember the equation of strain. It is delta L by L, right? So it is nothing but the fractional change in length. Okay, so strain is a fractional change in length. Next question. Metals used in the strain gauge have dash temperature coefficient. Okay, so that is again another important question or another important area. So the metals that we use in the strain gauges have linear temperature coefficient of resistance, and due to this, when there is some temperature variations, the resistance of the strain gauge wire will also get affected. So we have to do temperature compensation. Okay, so please note this point also. Temperature compensation should be done in the strain gauge wires. Okay, why? Because the metals or the metal wires that we use in strain gauges have linear temperature coefficient of resistance. Okay, so when the temperature is varying, the wire's resistance will also change. So we have to perform temperature compensation to avoid the errors in the measurements. Okay, so otherwise when there is a temperature variation, our resistance reading will get wrong due to the change in temperature. Okay, so due to this you have to do temperature compensation also. Okay, so next question. A Wheatstone's bridge has dash sensitivity. So a Wheatstone's bridge is a very high sensitive device because when we are measuring the change in resistance, it should be very much accurate, and only then we'll get the correct value of our strain. Okay, so we have already seen the equation connecting the change in resistance and the strain and the gauge factor and everything. So in that equation, if the change in resistance is accurate, we'll get the accurate strain value. Okay, so the Wheatstone's bridge is a high sensitive device and it has to be high sensitive also. Next question. Basically, strain gauges are classified as dash. It is basically classified as 3, even though there is another different variations of strain gauges. So the basic one is electrical, mechanical, and optical. Okay, so in electrical type of strain gauges, which we have seen in this video, so generally we'll take the change in measurement of resistance, or sometimes it can be capacitance or inductance also. For mechanical, we measure the change in length. Okay, and for optical, we actually make use of mirrors. Okay, so these are the 3 categories or the 3 basic classification of strain gauges. I'm telling it once again, there are other sub variants also. Okay, so in this video we have seen about the strain gauges. We have seen the basic principle, the basic structure, and also we have seen the important equations also. And the most important thing, we have seen 10 important questions from the strain gauge session. Okay, so if you're preparing for some competitive examinations, the questions are very important. That's why I'm including questions in all my videos. Okay, because only if you see the questions, you get familiar with it, only you'll get the advantage. Okay, so I'm really hoping that you found the video useful. If yes, please do give it a thumbs up. Please do share it maximum, and also please help in the growth of the channel. Okay, so that's it. If you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.